Welcome to today's lesson of Everyday Mathematics. This lesson is coming from lesson 2.10. You can find your work on Student Math Journal, page 57, and inside your student reference book, pages 229 and 233 for extra help through the lesson or after the lesson is complete. Classifying triangles. Today's agenda will be a warm-up with a mental math and fluency, a brief math message, the focus, which will include an overview, the vocabulary, reviewing properties of triangles, and classifying triangles by angle properties. Finally, we'll end our lesson with guided practice and independent practice by identifying triangles and working together on page 57 in our student math journal. Let's do a quick warm-up. Please answer the following questions. Write your answer inside of your personal mathematics notebook or journal, and then we'll check our progress. You may pause the video now. Compare the answers in your personal journal with the answers on the screen. Put a check mark by the ones that you got right, and just cross out the ones you got wrong and put the correct answer. In your personal math journal or notebook, list all of the things that you know about triangles. Now, don't forget the lesson that Mr. Gonzalez taught about angles, remembering obtuse, acute, right angle. Use those clues from that video to try to put some information down. Write at least 3 things down that you think you know about triangles. Pause the video briefly now to give your students time to write. In this lesson, students will learn to classify triangles by angle properties. Here's some academic vocabulary / information on clarifying triangles. An acute angle is a triangle with an angle that measures less than 90 degrees. Obtuse triangle, a triangle with an angle that measures more than 90 degrees. Right angle, an angle that measures exactly 90 degrees. So the way we can think about this is that acute angles are less than, obtuse angles are greater than, and right angles, if you hold your arm, one in the air and the other to the side, it makes an L. We can think of our head as the angle in a right angle. Equilateral triangle, a triangle that has all equal sides. Isosceles triangle, a triangle that has at least 2 equal sides. And finally, scalene triangle, a triangle that has no equal sides.
What I want to do in this video is talk about the 2 main ways that triangles are categorized. The first way is based on whether or not the triangle has equal sides, or at least a few equal sides, and then the other way is based on the measure of the angles of the triangle. So the first categorization right here, and all of these are based on whether or not the triangle has equal sides, is scalene. And a scalene triangle is a triangle where none of the sides are equal. So for example, if I have a triangle like this, where this side has length 3, this side has length 4, and this side has length 5, and this side side has length 5, then this is going to be a scalene triangle. None of the sides have an equal length. Now, an isosceles triangle is a triangle where at least 2 of the sides have equal lengths. So, for example, this would be an isosceles triangle. Maybe this has length 3, this has length 3, and this has length 2. Notice, this side and this side are equal, so it meets the constraint of at least 2 of the 3 sides have the same length. Now, an equilateral triangle, you might imagine, and you'd be right, is a triangle where all 3 sides have the same length. So, for example, this would be an equilateral triangle, and let's say that this has side 2, 2, and 2. Or if I have a triangle like this, where it's 3, 3, and 3. Any triangle where all 3 sides have the same length is going to be equilateral. Now you might say, well, Sal, didn't you just say that an isosceles triangle is a triangle that has at least 2 sides being equal? Wouldn't an equilateral triangle be a special case of an isosceles triangle? And I would say, yes, you are absolutely right. An equilateral triangle has all 3 sides equal, so it meets the constraints for an isosceles. So by that definition, all equilateral triangles are also isosceles triangles, but not all isosceles triangles are equilateral. So for example, this one right over here, this isosceles triangle, clearly not equilateral. All 3 sides are not the same, only 2 are. But both of these equilateral triangles meet the constraint that at least 2 of the sides are equal. Now down here, we're going to classify based on angles. An acute triangle is a triangle where all of the angles are less than 90 degrees. So for example, a triangle like, a triangle like this, maybe this is 60. Let me draw a little bit bigger so I can draw the angle measures. So a triangle, and it's a little bit less, I want to make it a little bit more obvious. So let's say a triangle like this. If this angle is 60 degrees, maybe this one right over here is 59 degrees, and then this angle right over here is 61 degrees. Notice they all add up to 180 degrees. This would be an acute triangle. Notice all of the angles are less than 90 degrees. So less than 90 degree angles for all of them. A right triangle is a triangle that has one angle that is exactly 90 degrees. So for example, this would be, this right over here would be a right triangle. Maybe this angle or this angle is the one that's 90 degrees. And the normal way that this is specified, people wouldn't just do the traditional angle measure and write 90 degrees here. They would normally do this little, they would draw the angle like this. They would put a little, I guess you could, the edge of a box looking thing. And that tells you that this angle right over here is 90 degrees. And because this triangle has a 90 degree angle, and it can only have one 90 degree angle, this is a right triangle. So that is equal to 90 degrees. Now you could imagine an obtuse triangle based on the idea that an obtuse angle is larger than 90 degrees. An obtuse triangle is a triangle that has one angle that is larger than 90 degrees. So let's say that you have a triangle that looks like this. A triangle that looks something like this. Maybe this is 120 degrees, and then let's see, let me make sure that this would make sense. Maybe this is 25 degrees, and maybe this is 30, or maybe that is 35 degrees. This is 25 degrees. Notice they still add up to 180, or at least they should. 25 plus 35 is 60, plus 120 is 180 degrees. But the important point here is that we have an angle that is larger, that is greater greater than 90 degrees. Now you might be asking yourself, hey Sal, can a triangle be multiple of these things? Can it be a right scalene triangle? Absolutely, you could have a right scalene triangle. In this situation right over here, actually a 3, 4, 5 triangle, a triangle that has lengths of 3, 4, and 5 actually is a right triangle. This right over here would be a 90-degree angle. You could have an equilateral acute angle, acute triangle. In fact, by all equilateral triangles, because all of the angles are exactly 60 degrees, all equilateral triangles are actually acute. So there's multiple combinations that you can have between these situations and these situations right over here.
Let's take a look at properties of triangles. Properties describe the characteristics of an object. Attributes simply refer to the additional information about an object, such as the fact that tri means 3. Most of the time, the words are used interchangeably as synonyms. Let's take a look at some properties of triangles. A triangle is a 3-sided polygon. A triangle has 3 vertices. The prefix tri, as mentioned before, means 3. And there are different types of triangles. The lengths of a triangle's sides can vary, which means they can be different. The angles in a triangle can be different sizes. And triangles are triangles even if they are right side up or upside down, on their backs, on their fronts. Whatever the case, as long as it has 3 sides and 3 corners, it is considered a triangle. Triangles have vertices, which is the irregular plural form of the word vertex. One way to identify different types of triangles is to classify them by their angles. Take a look in the first example. I've highlighted each of the vertices red. Excuse me. The red corners represent the vertices. Each one of those by themselves are known as a vertex, but when you say more than one, we use the word vertices. On the other example, we have more examples of triangles based on their characteristics and attributes, and then their names. And just like in the video, we learned that triangles can be referred to by more than one name, depending on their attributes and properties. Triangles versus equilateral triangles. Here's more information about triangles. Maybe you know it already, but triangles have fewer sides and angles than any other polygon. All triangles have vertices, 3 sides, and 3 angles. The symbol for the triangle is simply a small triangle. And if you're writing out the letters for a triangle, you'll always put the triangle first, followed by the letters of the sides. Triangles, when drawn out, have 3-letter names. You name a triangle by listing each letter name for the vertices in order. Triangles have many different shapes and sizes. And if you look at the below example, it says the above triangle can be called triangle ABC, triangle BCA, triangle CAB. What other ways could we name the triangle at the top? Think about it. Next, equilateral triangles have 3 sides that are all the same length. They come in many different sizes, but all equilateral triangles have the exact same shape. And these are things that we saw in the video. This is just to reintroduce and kind of reaffirm the information that you've already heard. Right triangles have one right angle, which is a 90-degree angle. The right angle is the biggest angle in the triangle when you're writing or drawing a right triangle. The side that is opposite of the right angle is always going to be the longest side of the triangle. The two line segments that intersect to form the right angle are perpendicular, and a perpendicular line segment forms a 90-degree angle. Finally, they have many different shapes and sizes, as we've heard for the case of lots of different kinds of triangles, no matter the shape, no matter the size. Take just a moment to look at the 4 questions below to see if you can classify some triangles by their angle properties. Write your answers down in your personal journal, and then we'll check to see if you're correct. First question, what do you call a triangle with one obtuse angle? Question number 2, name a triangle that has 3 acute angles. Number 3, a right triangle has an angle that is exactly how many degrees? Number 4, what can we name a triangle with only 2 acute angles? Pause the video now so that students can have time to write their answers. Here's the answer to question number 1, obtuse triangle. An obtuse triangle is what we call a triangle that has an obtuse angle. Now remember, that means that the angle is going to be larger than 90 degrees. Next one, question 2, acute triangle. Any triangle that has 3 acute angles will be known as an acute triangle. And keep in mind, acute means that the degree is going to be less than 90. Next answer, right triangle. A right triangle has exactly 90 degrees. And if you said 90 degrees, you are absolutely correct. Finally, obtuse or right triangle is the answer to this one. It just depends on the third angle. Let's dive a little bit deeper into classifying triangles.
Classifying triangles based on angle properties. Remember that a polygon is a closed two-dimensional shape and made up of line segments only. Segments only. Triangles are polygons with 3 sides and 3 angles. Like other polygons, triangles have many properties, and they can be classified based on these properties. Here, we will look at angle properties for triangles. As we learned before, there are 3 types of angles: right, obtuse, and acute. Let's take a look at this triangle. Notice that this angle is a right angle. If a triangle has a right angle, then we call it a right triangle. So this triangle is a right triangle. Here's another triangle. As you can see, in this one, we have an obtuse angle which is larger than the right angle. Also, if a triangle has an obtuse angle, then we call it an obtuse triangle. What about this triangle? As you can see, it has no right angles or obtuse ones. All of its angles are acute. This type of triangle is called an acute triangle. Now, let's look at the following group of triangles and try to classify them into right obtuse, or acute triangles. This one is a right triangle, since it has a right angle here. While this one is an obtuse triangle, because it has an obtuse angle within it. This triangle is an acute one, since all its angles are smaller than a right angle. This one is also an acute triangle. This might be hard to see, but it is a right triangle. We can use our right angle model to double check that this angle is indeed a right angle. This one is a right triangle as well, while this one is an obtuse triangle. Finally, this one is an acute triangle. In this lesson, you learned how to classify triangles based on the presence or absence of angles of a specified type and identify right triangles.
On this slide, you'll be able to use this practice to have worked examples and to help you classify triangles with some practice. There's also an article that you can look up or use to help you with this practice. Now you'll pause the video, go into your slides, open up these works, and then continue the rest of your lesson with your teacher